So as I said, we will finish this thing today, and we were almost closing to the end uh, yesterday. So basically, now we have computed the debiased of form of all the words, all the words in N, which were all stereotypes, and this we have achieved using the neutralize step. And we have also equalized all the words in the equality set So this is a set of sets. And to remind you, each of these equality sets could be like gal, guy, etc., etc. And this stereotypical set is which should be ideally gender neutral. These were like nurse, doctor, etc. So now you have new embeddings for each of these. After this algorithm has been executed, you have new embeddings here, and you also have new embeddings here. After the neutralize and equalize steps. Now my evaluation. What do you think should be the first thing that one should evaluate? After you have changed all the vectors, okay, in N as well as in the equality sets, what do you think should be the first thing that one should evaluate? Any thoughts? So what are these embeddings generally used for? What are these embeddings generally used for? We have seen, right? We started with this motivation, right? So like we want some of the problems to be solved using embeddings. So typical uses of embeddings are to measure word similarity. Let's call this task WS. Okay. Compute analogies. Let's call this task analogy. Fine. So these are some of the tasks that typically a word embedding uh, like is used for. So we use word embeddings in order to solve this kind of tasks. So after the re-embedding, what should one expect? Hmm? After the re-embedding, what should one expect? So suppose before the embedding, you were getting some word similarity performance, you were getting some analogy computation performance. Now after re-embedding, would you like to have the same performance or not? So the embedding should be usable, right? After re-embedding, the embedding should be still reusable for their original tasks. That should not be disturbed. So if I was doing some X performance on some task and now I am changed, my performance should not degrade. Now I am changed for some other objective. My performance in the original task should not degrade, right? And therefore, the authors measured, like on some standard data sets, the authors measured the performance of the original embeddings. This was the first thing that they established: original embeddings and the debiased embeddings. And on two different data sets, the word similarity task and the analogy task. So these were standard data sets that they took, and they measured the performance. With the original embedding, it was 54.5. With the debiased embedding, this was 54.1. With the original embedding, it was 57.0. With the debiased embedding, it was again 57.0. So what do you see? What is your observation from this? What can you comment about the quality of the new embeddings? How are the quality of the new embeddings? Huh? How do you think are the quality of the new embeddings? Bad, poor, as good as? Okay, let me give you some multiple choice. Which one would you choose? No idea.
So their performance is almost the same.
Very good. So they are as good as. So this is what we wanted to show. The authors wanted to show that the debiasing does not hamper the quality of the original embeddings. Okay, so debiased embeddings are as good as the original embeddings for traditional tasks like word similarity and analogy. Okay, so this was the first thing that they established. So the quality of the debiased embeddings have not become poor due to this debiasing algorithm. Now they have to show that they have been able to reduce direct bias and they have been also able to reduce the indirect bias. Now, how did they do this? The first one. So again, they had those 150 analogies like earlier. Okay, 150 analogies like earlier, and they asked people to judge the stereotypes. AMT workers, they judged the stereotypes. Okay, now what they find is that while earlier there were 29 cases, if you recall, of stereotypes, after debiasing, there were only 9 cases. So this was kind of a huge success. Okay, so there was like from 29 cases, it changed to just 9 cases. Okay, this was a huge success actually. So if you see, there is like this was like 19%, this reduced to 6%. Okay, so this was a huge success for the authors. Now, how did they check that the indirect bias is reduced? So there is no ground truth for this. It is difficult to show that the indirect bias is also reduced in there after they had run the debiasing algorithm. So in order to show this, they took the support of, or they resorted to the same football softball example, and they just showed it against that example. So now after debiasing, the softball extreme so before debiasing, after debiasing. Okay, so before debiasing, the softball extreme had bookkeeper, receptionist as the closer ones. But now new words have taken their place, like infielder, major leaguer, which are much more connected to the profession, okay, rather than being connected by the similarity in the gender subspace. These are connected based on the professional similarity. Similarly, on the football extreme, earlier you had businessman, you had maestro, etc. Now you have things like midfielder, footballer, which was also there earlier, which are more related to the profession rather than being connected by any gender-based similarity. Okay, so the authors show that they have been successful in removing both the direct and the indirect biases in the new embeddings. Okay, so there is only one thing that is left in this whole uh, pipeline of things, is this question of N. So what was N? What was N? What was N? These were gender stereotypes, right? Now, who will give me this list? Nothing comes for free. How will I build this list? So the authors had to take a lot of pain to build this list. Okay, all this time we were assuming that this list is given to us. This list is provided. But who will give this list to me in the first place? Okay, there is no such standard list of gender stereotype occupations. So we need to generate this list. But it seems that it is not so easy to generate this list. Okay. However, what is more easy is to build the list of S, which is the gender specific words. So what the authors did, they took up a dictionary, okay, and marked all those words that they found to be gender specific in their original set of W words. So you remember W was the original set of words that were taken from the W2V news corpus, and this size, the size of W was around 26K. Right. So from this W, looking at this W, glancing at this W, they manually marked all those cases which they thought, like as per a dictionary, which they thought are gender stereotypes, like gender specific words, like say she, he, mother, father, etc. Whatever they could find in this list of W. Now that set of W, that subset of W, they call S0. Okay, so S0, they started off with an initial set of 218 words. Fine. So out of this 26377 words, 218 words were marked as S0. And you had another, this minus S0 words left. Now, if you recall that the entire corpus was much bigger, okay, so we did some pre-processing in order to arrive at this 26,000 words. So now they looked back into the entire corpus, okay, they looked back into the entire corpus, so which was kind of 3 million words. This was 3 million words. Now what did they do? They had S0 as 218 words. Let's say S0 complement, which is like W minus S0. These they said are plus ones, and these they said are minus ones. Okay, so each of them is an embedding. Okay, so each of them is an embedding. So basically, let's say you have W belonging to S0, then the feature is W and the label is plus 1. And let's say you have a W prime belonging to S complement. This means W prime is the feature and minus 1 is its label. So in this way, you obtain a training set, okay, of like those which are belonging to S0 and those which are outside S0. Okay, those which are belonging to S0 are plus 1 labels, those which are outside S0 are minus 1 labels. And the embeddings of these words are directly features. Now, using this, you train an SVM. They trained an SVM, you can train any classifier as such, any binary classifier as such. So they train an SVM, and now they passed those 3 million minus W words. Okay, so not those W that have been already considered. Those 26K words are removed from these 3 million words, and now they are classified into plus 1 or minus 1. Okay, in this way, they could classify some of the words from these 3 million words as positive. So basically, those are also genders. Those are also gender specific words. They call these set S1. Okay. Now they build the final set S as S0 union S1. Okay. And this actually gives them 6449 words. So now N can be calculated as W minus S. So this is S and N can be calculated. You know the W set already. Now you subtract S, remove all the words in S from W. The rest is considered to be N. So in this way you construct N. Okay, so now you have all the things in your disposal and you can run your experiments to obtain the desired results that I have showed you. So this ends our fair embedding segment. Okay, in fact, this ends our entire fair ML part of the course. Now, the next part of the course would be about platform governance or content governance. So we'll talk about this. So let me just stop the recording for a short moment because I want to have that as a fresh recording.